So the first thing I did was draw a picture. I set it up so that the diving board was 1 meter above the surface of the water, and then I knew that the pool was 4.5 meters deep. So I wrote from the base of the triangle to the surface of the water is 4.5 meters. Also, we know that the diver reaches her highest point 2 meters above the diving board. So we can add together 2, 1, and 4.5 to get a height of 7.5 meters. We also know that the camera is placed 0.8 meters from the end of the diving board. So that is one of the legs of the triangle. Assuming a right triangle, we can use the equation tangent of theta is equal to height divided by 0.8 to solve this problem. We know that as the change in height of the diver over time is equal to 5 meters per second. And we know that the camera is placed 0.8 meters from the end of the diving board. So we want to find the rate at which the camera angle is changing when the diver is at 2 meters, which would be a total height of 7.5 meters. So the first thing that you do is you set up the equation tangent of theta is equal to h divided by 0.8, and you find the derivative of both sides. Knowing your trig identities, you know that the derivative of tangent is equal to secant squared of theta. But since theta is not in the argument we used, we have to do times d theta dt and set that equal to, before actually taking the derivative, of d dt h divided by 0.8. Now we'll work on the other side. Secant squared of theta d theta dt is equal to 1 over 0.8, taking out the constant, times the derivative of h. Continuing to work on that side, you can rewrite it as secant squared of theta of d theta dt is equal to 1 over 0.8 times dh dt. This is good news since we're given the amount for dh dt at this point in time. Next, you solve for d theta dt. So d theta dt is equal to 1 over 0.8 secant squared of theta, since we divided both sides by secant squared, times dh dt. Since secant squared is in the denominator, we can move that up to the numerator as cosine squared. So d theta dt is equal to cosine squared of theta divided by 0.8 times dh dt. Now let's plug in the numbers that we're given. D theta dt is equal to 0.8 over 7.543 squared divided by 0.8 times 5. Now, in order to get the value for cosine squared of theta, I did a Pythagorean theorem. Drawing a triangle, you can see that since we're given the one leg as 0.8, the other leg as 7.5, if you do a squared plus b squared equals c squared, you can solve for the third side to equal 7.543. Plugging that into the cosine equation, you get 0.8 over 7.543, and we square it since it's cosine squared. Now, using my calculator, I plugged in all the numbers and got that d theta dt is equal to 0.070, rounding to 3 decimal places, radians per second.